Hi, so here you can relate with the IV curve of Zener diode to that of simple diode. So as explained in the previous module, we've seen that the Zener diode works primarily in the region, reverse bias region. So how is that? So you can see this is the forward characteristics of a normal diode, and it is also a forward characteristics of a Zener diode. So this is your current I, this is your voltage across the diode. So when your diode voltage crosses the cut-in voltage or the threshold voltage of the PN junction diode, it turns on and the current starts exponentially growing, and it is clearly shown. However, what about the reverse situation? In a normal diode, usually you keep on increasing the voltage and there is a very small current flows through the PN junction from cathode to anode, that is called as reverse leakage current, and due to that you have a very small amount of current. But if you keep on increasing the voltage in a normal diode, you have a point or a voltage called as breakdown voltage of that diode. So for a silicon diode it could be like 30 volt or 50 volt and so on and so forth, depending on the type of diode. Once you exceed that voltage, when diode is biased in a reverse biased way, there is a point called as breakdown point, and a sudden heavy current starts flowing through that diode. It is called as reverse breakdown voltage, and the current is called as reverse current through the diode, and the phenomena is called as breakdown avalanche breakdown. So avalanche means there is a sudden heavy current flows through that may damage your diode. So it's ideally your diode conducts the current in a forward bias, and then in a reverse bias it is turned off and you never exceed this voltage. However, Zener diode are specially designed to operate in a reverse voltage. So what happens is that for a Zener diode there is a heavily doped PN junction that is manufactured. So you have P and you have N, and you apply positive here and you apply negative here. So due to very heavily doped P and N regions in a case of Zener diode, this diode has a lower breakdown voltages, and it is specially designed to operate at a breakdown voltages. So what happens in case of a Zener diode, when you have a reverse voltage, the breakdown happens when that voltage exceeds the breakdown voltage of Zener diode, which is about, let's say, 5 volt, 7 volt, or even less than 3 volt, depends on what kind of diode is that. So when that happens, it conducts the current then as shown right here, but it doesn't damage the diode, and as the current increases or decreases, it maintains that voltage across the diode. So again, this voltage is called as a breakdown voltage of a diode or Zener voltage of a diode, and that voltage is used in variety of application when diode conducts the current. I am talking about Zener diode. It helps to provide a stable reference as a voltage reference in a variety of circuits, such as amplifier, reference to the amplifier, and it is also used, Zener diode is also used in a stabilized power supply. So even if you have the variation in the load, your Zener diode will maintain this voltage across it, and it will provide a constant stabilized voltage to the load. So that was all about understanding the difference between Zener diode and a normal diode. So hope you like this video. If you did so, share with others.